Could you clap, please? Attaboy. Okay. Which pass is this, Danielle?
This is McKenzie Pass.
And you take your students up here regularly?
Yeah, we definitely visit here. There's these very recent lava flows, which are spectacular. And then just 360-degree view of mostly cinder cones and shield volcanoes.
Yes.
But also Middle Sister, which is really more of a typical stratovolcano.
Wow.
We can't see South Sister from here,
Okay.
but it's there.
Yeah. Let's start over here. Adam, you want to take over? What?
Sure. So if we just do the 360, we have Black Butte here,
Thank you.
which don't know if we've seen before today, but it's kind of an interesting volcano because it's just as old as any of these heavily eroded volcanoes that we're also looking at, but because it's further east, the idea is it's received less precipitation, so less glaciated.
Okay.
And if we come around, we can actually, that straight line on the horizon just to the left of Black Butte is the bounding fault scarp of the Graben, a place called Green
really?
Ridge.
Wow.
So you actually get to see it, yeah.
That's Green Ridge.
And then further around, the next most notable one is Mount Jefferson, which is the snowy peak.
Beautiful.
Again, I think the last eruption there was tens of thousands of years ago. Then we come further around to Mount Washington, which we've seen a couple of times already. We see it's an interesting edifice because its shape really changes from perspective. Here it looks like a fin.
Yeah.
If you go around, it's like it's just that top summit bit is more just like a little pimple that sits on top. And then the next thing is an interesting place. That's called Little Belknap Crater, and that's one of the youngest vents here, a couple of thousand years old. That's sort of you can see the dark area in the foreground here with this little
pimple.
little red pimple on top.
Okay,
That's
yeah.
the vent. And that's actually a satellite vent for Big Belknap, which is the tan-colored volcano that's next to the left. And both of these have produced a number of youngish, like late Holocene lava flows. So that sort of Belknap is a medium-sized shield volcano, or getting that direction.
Yeah.
And it's produced a lot of the flows that we actually see around it. Not all of it, but a lot of the flows that we see around us have actually come from Big Belknap or Little Belknap in the last few thousand years. And I will point out too, beautiful kapuka, which is a Hawaiian word, which is what happens when you have an older forest or older ecosystem surrounded by lava. And so the two little beautiful kapuka there.
Beautiful. Danielle, you want to keep us going and go back to the south across the road?
Yeah, I'm actually going to have to cheat for some of those smaller ones.
Right.
So South Belknap Cone is this one that's just poking up above the Kapuka.
Okay.
And then it looks like Scott Mountain.
Yeah, Scott, yeah.
And then, we're going to get into somewhere I'm going to have a hard time. There's Horse Pasture Mountain
Okay.
and Condon Butte. And I'm guessing those are these two here, because the next one is the Husband, which I think we're just seeing poking out in the distance.
Okay. Yeah.
And then we get up into Middle Sister and a beautiful glacier exposed there. That's Collier Glacier.
On north or middle?
On Middle Sister. So
Okay.
the big
Yes.
sloping ice field
Okay.
that we're seeing. And then North Sister, we are seeing glacial ice there, but very small.
So,
And then
please.
if we work back around over to the left of North Sister, there's this Matthews Fissure system that we're seeing some of that kind of exposed in those red slopes.
Okay.
Also kind of have to look through the trees.
Sure.
And then if we just come this way just a little bit,
No,
and then
let's just keep walking.
Black Crater is this shield volcano in front of us that was glaciated. There's a small cirque, and we're seeing some ice-carved cliffs at the summit.
Yeah, I do. I did have that there.
So do you visualize a lot of ice up here?
2 extra
Danielle?
bones growing like on the inside of my ankles.
Well, I do visualize ice, but not on this surface, because this is all, 3,000, 4,000, some even younger year lava flows. So I guess you start thinking in time at that point. that yes, at one point or multiple points in time, this had big sheets of ice on it, but this surface was never glaciated. This is so young, and this is just another really good example of these volcanoes are so young, so active that they've really covered up a lot of the glacial record.
I mean, that's one of the things I'm going to say to anybody who says, you were down in Central Oregon Cascades? Yeah, what was it like? It's like, I just can't believe glaciated valleys have been filled with all sorts of lava since then. Like, we just don't have that in Washington. We just don't have that in Washington. I mean, we're up at a pass, and these lavas are just decorating these formerly glaciated valleys. I just find this incredible. And most of this in the foreground is coming from Little Belknap. Is that what?
I think this actually comes from the other side. So there's sort of a drainage divide.
Okay.
I think the middle ground is definitely Belknap, and then it flows down into that, not a drainage, but low point.
Right.
And I think this flow actually comes from Yapoa, which is coming from the other direction.
Mm-hmm.
Why not? Let's go up around the corner here and just do a little bit more with the sisters if we can. So assuming people are going to see this McKenzie Pass geology video and not the sisters video, let's do a little bit more with differences between north and middle. And anything else you want to do. Wow. Adam's Apple Watch is going crazy. He's doing online sports betting while doing a geology video.
So what do you think, the top first and then the quirky viewpoints?
Yeah, the quirky viewpoints might make really nice video.
Yeah, they are really cool. I like that.
Thank you.
It's a nice map of the
lava
flows. I don't know if he's going to want to use that or not, but
nice.
So you've done it a million times, Danielle, but what are some key differences between North Sister and Middle Sister?
North Sister is much older, much more eroded by ice, and compositionally it's all mafic material.
Okay.
And South Sister has much more variation. It's much younger.
South? Are we looking at south or middle?
Sorry, I'm middle. I'm
okay.
sorry.
That's
Middle
fine.
Sister is much younger.
Yeah.
And more variation in the composition. Also eroded by ice, but less eroded because it's younger, and we kind of see that difference in the shape and how it holds ice now.
Beautiful. What else strikes us here?
We can see Hoodoo where we were.
Oh yeah. Yeah, you're right. That's
the south side of Hoodoo.
What if someone could like mess with this and then it would be like north this way?
But not Hayrick.
Yeah, it's weird. We don't see Hayrick. Hoodoo is a couple of 100 feet higher than Hayrick, but.
And then this in the foreground, it might be blocking.
Yeah.
Although it might not stick up past that anyway.
The Green Ridge is really coming into view. The Graben bounding fault there.
That's pretty impressive.
Yeah, it's a really good example. There is clearly a bounding fault there. I think it's a good case there's a bounding fault roughly this latitude on the other side. But as we saw, as we push back towards Bend, the structural evidence for that becomes less, at least topographically. And so then the main probably evidence after that is the age of basalts of the type you would expect to come from that extension and decompression that they young to the north, which is sort of what you'd expect if you started propagating a graben from south to north. So there's that. The other thing this is getting a bit basalty technical, but the other thing I've always wondered is, extension rates are super low here. Like they're measured to be a millimeter per year or less, which is at the very low end of sort of global extension rates.
Okay.
And normally the idea you extend, then the mantle bobs up and it melts and produces, that's how you get melting associated with rifting. And I just wonder whether there's been enough extension to actually make that all work.
Yep. Makes sense to me. Nice.
I love that little cinder cone on the top of Little Belknap.
Yeah. That's one of my favorite hikes, actually.
So if you were to write a PBS episode here, what's the main story? Is there one main mystery? Here, I think I have the story at Santiam Pass about how much ice and how thick and how old. That's really not the main story, either of you. Like if you're now into producing geology videos for public television.
I mean, the recent lava flows seem like the main story here just because they're just so well exposed. That's what you're overwhelmed with when you get here. But what's the mystery with
I
them?
mean, to me, the mystery is it a mystery? But this is a place where most recently there's been a big focus of this type of volcanism. That's not the case everywhere. Santiam Pass, there's almost no young volcanism like this. But here, you come here and there's 5 or 6 vents that have had Holocene eruptions, maybe more actually.
That's it.
Well, there is the Sand Mountain chain, though.
I guess there is yes, you're
is
right. Yeah.
Many vents all
that's true.
all erupting at the same time.
So I guess maybe it's just a good example of a place where you have this temporal pulse where lots of vents have come up. In this case, they're not quite like Sand Mountain or Bachelor where they're all along a single fault. They're a bit more spaced out. I don't know if there's an obvious structural control. There's one beautifully structurally controlled vent up there, which is 4-in-1 cone, which has 4 little cones in a row. But
you can see the little,
you can
those
actually
3
see
little bumps are part of 4-in-1 cone. We're
yeah.
not seeing all of it.
Yeah.
And that trends along the same trend as, this sort of north-south trending chains that we've seen in the Mount Bachelor chain and the Sand Mountain chain. But yeah, you're right, Adam. Then there's these other cones that are off, just one cone here, one cone there.
Right. Well, I'll say it a slightly different way. This is a mountain pass in the Cascades. I can't think of another mountain pass in the Cascades that looks like this.
Oh yeah.
I mean, this is Craters of the Moon, or this is some hike out in Kilauea somewhere. This is shocking that this is significant elevation in a place that, if we just take an inventory of every major mountain pass in the Cascades, from northern Washington down to northern California, I just think of U-shaped valleys in Washington. White Pass, Snoqualmie Pass, Stevens Pass, North Cascades Highway. It's glaciated and there's no lavas anywhere, really. No fresh lavas. Then come down here in Oregon, you want to do the same thing? What's the first major mountain pass in northern Oregon?
Probably Government Camp, the one that goes over if we don't do the Columbia River, which is
right.
the one that goes over the south slope of Mount Hood.
Okay. Glaciated?
Oh, certainly glaciers on Mount Hood, for sure. But not like North Cascades, U-shaped valleys or anything like that.
I guess just the passes. I'm thinking of the experience of driving over each of these passes and crossing from eastern to western Oregon. There's nothing like this. What are the passes to the south of here, to the south?
Santiam Pass, where we were, we didn't see this, but if we had continued just a little farther down that pass, we would have seen this with more trees on the lava flow, but very similar lava flows.
Very similar.
Yeah, so we would have seen something very similar to this. It might have not have looked exactly the same just because of the amount of vegetation, but young 3,000-year-old lava flows.
3,000 at Santiam. And what's the age here?
I think the youngest is maybe 2,000, something like
Yeah, and 1,000. Collier, I think, is 1,600.
yeah,
The lava.
yeah.
And that's not actually here. That lava flowed down a glacier valley into the glacial valley and
Yeah.
partially filled. I mean, it doesn't fill the valley by any means, but it traveled along the floor of the glacial valley. So that's the youngest of these lavas. We can see some of it in the distance, but it's not what we're standing on.
Okay, now I'm going berserk because I'm so weird with my clock and time. Now I want to say, why isn't it forested? 2,000 years is plenty of time.
That's a really good. I mean, to me, that's maybe the biggest story here is the hydrological one. In that, if this is a seasonal road, so this is only open in summer.
Yeah.
Because it gets
It gets
tens of feet of snow.
So why is it forested one pass to the north?
It's lower elevation on the west slopes of the Cascade. We're at the very crest of the Cascades. These lavas flow downhill on both sides. The 3,000-year-old lava flows at Santiam Pass are lower elevation, and they have some of the tephra from those Sand Mountain eruptions.
Tephra.
So the lava and the tephra is both from Sand Mountain. So that can kind of give the vegetation a little bit of a hold, and it's getting, well, I don't know that I can say it's getting more precipitation. It's maybe getting more precipitation in the form of rain.
Yeah,
which
yeah,
might
that could be
impact.
maybe it. Yeah, yeah, it's true. I don't know that, but definitely the forest looks like it's getting more precipitation. But
I think I have some images here with tree canopy heights on lava flows, which is kind of cool. Something's biting me over here. Go away.
Good thing I didn't shower this morning and clean this place out.
yeah,
Nobody's
good.
coming
It's
up
good.
here, man.
It's good strategy. I wish I thought of it. So have you seen the drainage systems yet? Have you spotted them?
No.
Yeah, there's none. All the precipitation is just infiltrating. Yeah.
I mean, that is the story here, isn't it?
Yeah, it's
It's a sponge.
it's
This
remarkable.
thing's
Yeah.
The volcanic sponge.
Yeah.
And again, that plays a role in hazards because we can see it's young, active. We would expect future eruptions here. And we know there's a lot of groundwater. So they would be more explosive than if they were coming up through layers of rock that didn't contain groundwater.
Well, viewers, I'll put it to you as you watch this video at McKenzie Pass. Can you think of a mountain pass that has this fresh-looking lava decorating the entire mountain pass? And if it's 2,000 years old and there's been no recovery of the forests, and yet those guys are hanging on. Okay, so what land surface is that? Why are those forests there?
I mean, that's an older one, and they are two older scoria cones. So I think maybe the tephra soil thing is one reason they're a little more forested, and they're older. I don't know how old.
That's cool. This is cool.
And you can sort of see that a little bit up at the Big Belknap too. That has a pretty good tephra blanket. And so there's definitely more trees up there, even though those flows are still not super old up there.
And the horns alternating with rounded knobs, that's also pretty wild. Like, I can't think of a place that, if you're in the North Cascades, everything's a horn. Everything's been glaciated. If you go someplace else, it's the Appalachians or something, everything's rounded off. But they have this apples and oranges in the same scene. Kind of bizarre. Okay,
Got it all.
got it all. Following you guys. I keep filming. What's
Black
that?
crater.
Oh, really? Oh. Yeah. Oh, these CCC guys were thinking.
Yeah, their aim is true too. It's really, it's really accurate.
This one, they've got like I can't see it through here, but I saw it from the top. The tiny little tip of Mount Hood is poking up,
Oh yeah, I can see it from.
and they framed it.
Right there?
I can't see it through there, but I believe them because you can see it over here.
Yeah, I can just see it there. It's hard when it's framed like
The days were clearer when CCC
Yeah,
was
that's
out doing their thing.
Oh, I see.
I love this.
It's got, okay, so that's horse. That's that one. Well, that's a pretty minimal peak to get its own little window, but.
Oh yeah,
That's way. There's like, what about this one here?
but it's like Mount Hood. It's bigger. It's
Maybe-
just been
maybe, yeah, it's
covered
just
by.
further
I
away.
mean, it's not as big as Mount Hood,
Yeah.
obviously. But I actually haven't come in here in a while. This is fun.
Nice.
It is fun. I really like it.
I just imagine some 23-year-old kid like asking the supervisor, "Can't we do this? Like nobody's going to check. We got everything. Let's just add a little sizzle here.
Yeah.
Come on, boss."
Yeah, there's definitely a touch of art to that that aspect of it. I mean, it's beautifully made too. I think.
Did they have anything to do with the lodge on Rainier? Is that?
Possibly. I think all those beautiful national park lodges, I guess I just associate with the Park Service, but maybe not.
Yeah, no, maybe that was the Park Service.
Hey, which field guide is that? Is that one of the IAVC ones?
Yeah,
Okay, I'm gonna
Yeah,
get
it's this
myself a
big
copy of that one. Yeah, yeah. Oh, that one.
hydrology,
Yeah, yeah.
like there were a
Okay.
ton of people on
Yeah, I
this.
gotta get one.
Rick's got a bunch of stuff in here.
Yeah.
Yeah, it was a fun trip. But we put all this work into this part. We even had hikes, and we couldn't get up here because it was on fire.
Oh.
My God.
Yeah.
So there aren't that many active glaciers left, are there, in the
Oh.
Oregon Cascades, or are there?
They're I mean, there are some, but they're pretty pale resemblance of what they used to be, I think.
Yeah.
Like the Bend Glacier, which is on the north side of Broken Top, really seems to be just hanging on. It's kind of sad, that one.
Yeah,
I think some on the north side of the Sisters are maybe doing better.
Collier is definitely the largest, though, and it's much smaller than, even early photos in the early 1900s.
Or when you were in high school?
Or when I was in high school. Yeah, really. And then there are some where there's still, it's still technically glacial ice, but it isn't moving anymore.
Yeah.
Yeah,
I think
it's kind of
I
a
think
dead
that's
glacier.
the Bend Glacier maybe is in
Yeah.
that category.
Yeah.
Okay, that's a wrap.